So welcome again. As Alex said, my name is Les. I'm the Apache Shiro project chair. So when the project entered the Apache incubator system, and then we recently graduated, there's a chair that handles all the necessary board kind of logistics and paperwork and all that kind of stuff, and that's really what a chair does. So I'm the chair. Apache Shiro used to be called, or used to be an open source project named JSecurity. I was a founder of that project in 2004. And then when we switched over to the Apache incubator, we changed our name for legal reasons. They didn't know if there was some trademark violations that could have occurred. They weren't entirely sure about that, so it was just safe to change the name, and that's why we ended up changing our name to Shiro instead of keeping JSecurity. I am a founder and CTO of a company called Katasoft, and we as a company deal with application security products and professional Apache Shiro support and training for enterprise applications. What is Apache Shiro? Basically, it's an application security library that helps you as developers write more secure applications without having to work too hard. A fundamental tenet of the framework is that it's quick and easy to use. I had used a number of security frameworks and mechanisms prior to working on JSecurity and then Shiro. And a lot of them were complicated. They were difficult to understand. A lot of the programming techniques and paradigms in what existed was not sufficient for what I thought should be in a security framework. And the other founder, his name is Jeremy Hale, he and I both agreed on a lot of these issues, and so we got together and we started cranking out some code, and it eventually became what is now Shiro. But the key points are that it's easy to use. We want things to be simple. Things like cryptography and session management and authentication authorization, a lot of these things can be really, really complicated and overly complex. So the fundamental basis is super easy to use. That's what we really try to focus on in the code. And almost everything else is secondary to that. And again, we simplify a lot of security concepts. So we'll talk a little bit about cryptography and the Java Authentication Authorization Service called JAAS and some of these other things. We try to basically break all that stuff down to their essence and make it simple to use. So that's really what the whole point of the framework is. I'd mentioned a little bit about this before. We started writing code in 2003, so wow, it was 7 years ago. And then it became JSecurity as a project on SourceForge in 2004. So what we wanted to do from a framework perspective is that we really wanted to simplify or even replace what JAAS was. How many people in here have used JAAS as a programming technology? 3. Okay, that's pretty consistent with what I've seen elsewhere. I mean, 3, 4, maybe about 10% of an audience has ever used JAAS, which is a little surprising because that's Sun's default authentication and authorization framework that they intend Java users to use. Most people find it unbelievably confusing and difficult to work with. A lot of the object terminology and the concepts and classes are very confusing. So a lot of people just forego JAAS and they end up rolling their own, which is what I did in 2003 because it didn't make sense. And I had to solve some very specific security problems with a government application that were not satisfied by JAAS. So I had to go off and do all this stuff on my own, and then we decided to open source it and make it a framework. The application that I was writing at the time is pretty interesting. It required us to change our security model at runtime. It was for a government agency, and they had some crazy requirements where the application, if you were a user in this building over here versus another building over here, and you change the security policy over there, it had to be instantaneously reflected across all buildings that you could access as a person. And they sort of really pushed the limits of what was available in Java at the time. And a lot of those concepts got baked back into the framework. We wanted to reduce the design flaws that are associated with custom programming applications. A lot of times, when people try to incorporate security in their own apps, they miss a lot of things. A lot of people aren't security experts. They're just trying to get their business logic done. And so they end up rolling a lot of this stuff on their own. But it turns out that they end up missing quite a bit. from a security perspective. So we wanted to try to reduce the design flaws that occur from custom development and bake a lot of best practices into the framework. And hopefully we wanted to make it a one-stop shop for application security. So we had to do cryptography and session management, authentication, authorization. We didn't want to have to incorporate 5 or 6 different frameworks or API stacks in order to get it done. We wanted to just use one framework. And as I mentioned, Apache Shiro became a top-level project last month. So we just recently graduated. We were the incubator for almost 2 years, trying to resolve mostly team issues, commit history and stuff associated with becoming an incubator project. We wanted to make sure that was really sound and solid before we went top level. And so we just recently graduated last month. So now we're an official top level project. Thanks. Thank you very much. So, again, with design flaws, that's one of the things that we wanted to prevent in our system. You see stuff like this happen all the time in both software and in the real world, where you have a really great idea and then you kind of add on another really great idea. And a lot of times you'll see that they don't really mesh well together. So in keeping with that theme, we tried to solve as many problems as we possibly could to get developers off the ground and running with clean design principles. But there's no silver bullet. So although we try to do our best and make sure that 99 or 95% of all the edge cases are covered, there's still things that you as a developer are responsible for. You have to make sure you code your applications in the right way, that there's loopholes that even frameworks can't solve, and you're still responsible for those things, but we try to limit the amount of things that you have to worry about when you're using a security framework. So I don't know if you can see this, but this is an airport security checkpoint, and the guy's playing solitaire instead of looking at the people going through the thing. So, you can program a great system, but there's other things outside of the program or the source code's control that you still have to batten down. So just always be aware that no matter what security framework or technology you use, it's not going to do everything for you. So this is our agenda for tonight. We're going to talk about what I consider to be 4 cornerstones in application security. Like when you choose application security framework or when you have to implement it in your own application, there's 4 main things that you kind of have to worry about. Authentication, authorization, session management, and cryptography are kind of the 4 cornerstones of the framework. And then we'll also talk about some additional web support that Shiro provides out of the box for web applications. And we'll talk a little bit about threading, concurrency, how to use Shiro in a multi-threaded application, and some other miscellaneous things associated with these 4 cornerstones. But before we talk about those, I just want to get some terminology out of the way really quickly. Security environments can be complex. The terminology can be complicated. So there's a couple core concepts that I want to get everybody on the same page with. So when I reference these all the time throughout the application, we're all comfortable and we know what they mean. We talk about a subject quite a bit with Shiro and in security concepts in general. And all a subject really is, it's nothing fancy. It's just a security-specific view of an application user, right? It can be a human being, but it can also be a third-party process. It can be a server connecting to your application. It could be a cron job. Basically, a subject is anything or anyone that's interacting with your application. That's all it is. But it's a security-specific view of whoever that user is. We talk about principles. Principles in Shiro are whatever the subject's identifying attributes are. So first name, last name, social security number, username, any of those that kind of data that's an identifying attribute of a subject are principles. And you'll see this referenced regularly through not just our own documentation, but all over the net. Credentials are secret things that are used to verify identities. So passwords, biometric data, X509 certificates, a lot of these things are considered credentials, and they just prove an identity. And finally, a concept we talk about a lot in Shiro is that of a realm. And for our needs, we basically define a realm as a security-specific DAO. So Does everybody here know what the DAO design pattern is? Data access object. Yeah. It's just a software component that talks to a backend data store. But a realm happens to be a security-specific component that talks to a data store. So you can get username and password data out of an LDAP directory. You'll have an LDAP realm. You can have a local username and password in a relational database. You'll have an RDBMS realm. And the idea is that you basically want, or you can use a realm per backend data source. And Shiro will know how to coordinate these things together in order to do what it needs to do when your application's running. So that's what a realm is. So let's talk about authentication. We define authentication as identity verification. You're basically proving that a user is who they say they are. So just because I say I'm Joe Blow doesn't really mean I'm Joe Blow. I need to provide some sort of proof or credentials that the system understands and trusts to verify that I really am Joe Blow. So that's all authentication is. We'll contrast that with authorization later, but it's really about proving someone is who they say they are. Some features in Shiro that helps with authentication, or this is actually how Shiro performs authentication, is the concept is subject-based or current user-based. So you'll see soon that the API and almost everything that you do in Shiro is based on the currently executing user. You want to call APIs based on, is Joe Blow able to log in? Let me execute a login for Joe Blow. Everything in Shiro's API is very much focused on a single application user. The authentication process is a single method call. It's very, very simple relative to things like JAAS, where you have to set up multiple callback mechanisms and all that kind of stuff. So you make one method call and your user's logged in. We provide out of the box a rich exception hierarchy. So if anything goes wrong during the login, there's this nice hierarchy of things explaining why the login failed for any number of reasons. And also we have the remember me functionality built in. When you go to a website and you click the remember me box, how does it retain your identity across sessions? That's built into the framework. So those are really some of the core features of what it means to authenticate with Shiro. So how do we actually go about doing that? There are basically 3 steps to authenticate, and this is true of Shiro or any other framework for that matter. The idea is you basically collect some user data, username, password, X509 certificate, fingerprint, whatever, it doesn't matter. You collect that stuff, and then you send it off to the authentication system, and either it's successful and the user's logged in, or it's failed and they give you a reason why it has failed. So that's the basic gist of a 3-step authentication process, and Shiro models this exactly. So here is some code that represents how you do this in Shiro specifically. So the first step is that we need to collect some principals and credentials. Username, password, thumbprint, X509, all that kind of good stuff. In this particular case, we're using a class called a username password token. Very, very common. It's the most common token that would be used in the framework. But all we're doing is we're bundling the username and password that we've acquired some way in our application. Maybe they filled in a web form. Maybe that information was passed as an HTTP header. Maybe it was read off the command line. It doesn't matter how you acquire it. It's protocol agnostic. But you bundle that information into a token. And this little example shows here that we're setting remember me to true in this particular example. So we want the system to remember the identity of this particular user so they don't have to log in the next time they come back to the application. So we've collected the information into a token. The next step we need to do is submit it to the system. And it's 2 lines of code. What this means is, again, I mentioned before we were very subject-centric kind of an API. So what we have to do here is we use the security utils class, which is a core part of Shiro's API, and it will acquire the currently executing user via this call. And again, a subject is just a security-specific view of a user. It could be a human, it could be a process, it could be a cron job, doesn't matter. But we get back a subject instance representing who the current person is that's interacting with the system. And once we acquire that user representation, we just call the login method and submit the token that we just constructed a second ago. So again, really, really easy, single method. And after this method returns, if it's successful, they're logged in. You can go about using the application, and they're good to go. But the one thing that we got to cover here is what happens if something fails. What if they give you the wrong password, or they've accessed the system too many times? Maybe their account's locked. That's sort of where the exception hierarchy comes into play. So you can take that method call and wrap it in a try-catch block, and you can cache all sorts of exceptions if you want to handle them and react to them accordingly. So maybe there's an unknown account, they entered in a username that doesn't exist in the system, or an email address that doesn't exist. Incorrect credentials means that the password was incorrect. They gave the wrong verification. Maybe the account's been locked, not allowed to use the system anymore until it's been unlocked by an administrator. Or they've just now exceeded the number of attempts that was allowed before their account was locked. Or you can create your own exceptions and catch them and handle them accordingly. Or you can just cache the general exception and present some generic message to the user like, invalid username and password. Right? It's a common security practice to not give an end user too much information about what went wrong, because you don't want to assist them in any hacking attempts that they might be attempting. So exceptions can be thrown. You can handle them in any way that you want. You can either show them more detailed information, or you can keep it very generic. When this method is called, is that subject instance really a template? How does the username and password get associated with that subject instance during a login? And the answer is that in Shiro, there's always a subject instance available to the currently executing thread. There's always something that represents somebody is interacting with my code. They're anonymous at this stage in the game. There's no identity associated with them, and it's considered anonymous. After this method executes correctly, or without failure, with no exception being thrown, then the subject instance is associated with a normal user account. So it's anonymous up here, and at this point it's associated with an identity. In addition to just a normal login process, we support this notion of remember me. And in the subject that is authenticated, it supports in its API two methods. One is remembered and is authenticated. And in Shiro, it's very important to note that a remembered subject is not an authenticated subject. And we make that distinction for a lot of reasons, most of which is because it's correct from a security perspective. But I'll give you a scenario that helps sort of illustrate why this is important. Let's say you're using Amazon.com, and you've logged in, right? You've provided a username and password, you've hit enter, and you are legitimately authenticated. They've validated your password's good, and you use the application. You can add books and movies to your queue and all that kind of good stuff. But if you walk away from your computer and you come back, say, the next day, and your session has expired by then, and you come back to see Amazon, you go Amazon.com, hit enter in your browser, it will remember who you are because they've set a cookie on your browser, right? It knows, okay, this is user J Smith, and these are his books and movie recommendations, and I can give a personalized view of what that user does. But it can't really trust that you are who you say you are. Just because I'm using the browser the next day doesn't legitimately mean that it's me accessing that website. Maybe it's my wife or my child or something like that. So it doesn't really know that you are really J Smith. So Shiro makes that distinction in its API. You can check if they're remembered. It means that we've picked up your identity from a cookie or some other mechanism, and we can do authorization checks. We can represent the identity. But if you want to do anything specific, like on Amazon.com, if you wanted to say, go check your credit card information or make a purchase, they know the difference between the two states, and they will force you to authenticate at that time. Right? You can't go look at your credit card information until you've proven your identity. So that scenario occurs a lot of places over the web, and Shiro has that built into its API, so you can make that distinction yourselves. Whether or not you use either of these two things to customize your views is up to you as a developer, but at least the framework will maintain that state for you if you need to know. Where do the realms come into play? We talked about this notion of a security-specific data source. How is a subject and a realm related? And the answer is they're not really related too much. The way this stuff works at runtime is that your subject instance knows about a security manager that Shiro maintains. And the security manager is the thing that makes all of the stuff inside Shiro work. It knows how to coordinate realm instances. It can talk to session manager. It can talk to caching mechanisms, right? It's really this Uber object that knows how to manage all of these things. And so the process is when you submit an authentication token via that method call, the security manager then looks at that token and it knows how to delegate to respective realms that know how to handle that token. So you might have a realm that only understands biometric data. And so the security manager is smart enough not to give a username and password token to a biometric realm. Right? It knows what's supported, and there's some wiring that's going on under the hood, but it's smart enough to figure out, okay, for this token I need to talk to these number of realms, or for this token I need to talk to these realms. It can talk to multiple realms at the same time, aggregate data, and return a single unified view back to the application. So those kind of things are really specific to how you configure Shiro for an application, but the application developer via these mechanisms would never really worry about that stuff. So authorization is, we define it as the process of determining access control. Who has access to what? Am I allowed to look at this web page? Can I click on this button? Am I allowed to print to this printer? Those are all decisions determining what you have access to. So authorization is the process of access control. There are some core elements in the authorization process that we reference quite a bit. And those are permissions, roles, and users. We'll talk about what we mean by each one of these. So in Shiro, first of all, the concept of a permission is defined many different ways in various ways across different frameworks and projects. And we define permission as a statement of behavior. They're what the application is capable of. Can you print to a printer? Can you open a door? Can you push a button? Right? These are all actions on a particular resource type. So the permissions describe resource types and then what actions are possible when you interact with those resources. That's all they are. They're essentially the most atomic level of a security policy in an application. They have no knowledge or association or relationship to who can do these things. They're just statements of functionality and nothing more. Now, a role can be one of two things. Most people understand roles by what we call, or what we define as an implicit construct. Like, if I have the administrator role, I'm allowed to look at patient data. Or if I have a bank teller role, then I can open an account or access an account, right? Just the fact that these names exist don't really have a correlation to what the software can actually do, right? So most people use roles in this manner. We like to think of roles as a little bit more explicit than that. One of the things we like to focus on is that we can say that a role is really a collection of permissions. So because permissions are very granular and atomic and they specify exactly raw functionality, if you just bundle those together and then you associate a name with it, that's more of an explicit role. So if I have the administrator role and in that role it contains the all permission, that means I, as a user, can do everything in the system because my role has that permission, not just some implicit definition based on a string. And so when you use it in this manner, you can aggregate behavior. You can assign different permissions to different roles, and you can specify that these people over here can do X, Y, and Z, and these people can do A, B, and C. It's very, very concrete as to what actions can be performed, rather than just some interpretation of a name. And in Shiro, if you use this mechanism, you can dynamically add permissions to different roles, or you can remove them, and you can do this all at runtime. And your security model, when you do these subject calls, will always reflect the current runtime values that you've assigned to these things. So when a realm is eventually called in order to figure out this information, it can know this stuff dynamically at runtime. You can make a change and immediately see the result. This is a big deal because it doesn't require your end users of your software to log out of the system and then log back in again in order to pick up their new abilities. So the question is are you not caching anything? Do you go to the realm every time when you do this authorization stuff? And the answer is that Caching is a fundamental concept that's built into the framework across the board. So almost everything is cached, and there's mechanisms that allow you to interact with the caching to either invalidate cache entries or to determine time to live values. But yes, we use caching significantly across the framework to be able to handle the performance of constant runtime updates. So the question is do permissions have to be associated with roles? Does the library force that upon you? And the answer is no. You can assign you don't even have to use permissions at all if you don't want to. You can use the implicit concept of a role. If you do want to use permissions, you can model that however you wish. You can assign them to users, you can assign them to groups, to roles. You can assign permissions however you want. And ultimately, your realm implementation that talks to your data source, so a relational database or LDAP or whatever, it is the thing that will bring back that information and tell Shiro whether or not roles or permissions exist. So yeah, you have full control over that. That's permissions. Talked about roles, implicit and explicit, and finally we'll get to users. And we don't have a user concept in Shiro's framework, right? Our concept of a user is really the subject instance, because to us and to most people, the word user usually implies a human being, and that doesn't have to be the case with Shiro. But users are essentially the who of the application, right? These are the people or end users or subjects that can do things with your software. And it's through the association of users to roles or to groups or maybe direct permissions that those relationships determine what a user is allowed to do in your application. So one example is, let's say there is a printer on the second floor and it's LaserJet 4400N, that's the ID of it, and I want to be able to print to that printer and maybe manage it, right? You can create a printer permission object, and we'll cover this later, that represents the ability to print to LaserJet 4400N, right? And if that permission is associated with your user object or a role or a group or any of these other associations, then Shiro will return true. And it does that by querying your realm implementation to find out if it actually has that information. So that's it. So users can do things based on how roles and permissions are assigned. And you as a developer define the data model that makes this work, right? Because every application is different, every data model is different. So it doesn't force, it's like in Shiro, you don't have to implement a role interface or a permission interface if you don't want to, or a group interface or a user interface, right? We don't have any of those concepts. So you're not forced to, invade your own API with these mechanisms. The realm really acts as the buffer between Shiro and what you need to do in your application. So how do we do authorization in Shiro, right? So I want to check to see if the current user has the ability to do X, Y, or Z, or if they're in this particular role or not. It allows you to check based on roles and permissions. We provide a very powerful out-of-the-box wildcard permission construct that you can leverage in your own applications if you want to. So instead of writing permissions directly, there's this pretty cool wildcard permission that will take a big load of work off of you. And again, we can support any data model at all. Your realm implementation ultimately decides how these permissions and roles and stuff are grouped together and whether or not to return a yes or no answer to Shiro. So how do we actually perform authorization with the framework? Well, we've got three means of doing this. We can do it with programmatic checks, right? We can code this stuff into our application. We support Jdk 1.5 annotations. And we'll talk in the web support part later on, we'll talk about JSP and Jsp Tag Libs. So you can show or not show certain parts of your web page based on certain state in Shiro. So this is how you would do this in Shiro programmatically, right? We get access to the current user. You've seen this before for login. And then it has simple method on it, has role. So if the current user has the administrator role, maybe I'll show them a special button. Maybe it's the button that allows them to get into the management part of the UI or not. Otherwise, if they don't have the role, maybe I won't show the button. Maybe I'll hide it. Maybe I'll gray it out. It's up to you as a developer and your application's requirements to leverage this however you need to. So this is an example of using the implicit role construct, right? All I want to do is see if this user's in a role named blah. Does anybody see a problem with this? Is this a good thing or a bad thing to do in your source code? Any ideas? It's not necessarily bad or evil or anything, but what are some repercussions that can happen if you do this? Exactly. So that's part of the big problem with the concept of this implicit nature of a role. What if you need to add a role at runtime? What if you need to delete the administrator role or redefine it as something else? Maybe it's administrator 2 or who knows, right? If you were required to do that for your application as you specified, you actually have to go back and change all of your source code where this exists and change it to reflect the new roles. So when you use this paradigm, you can't delete roles. You can't even add them at runtime, right? It's impossible to do that because your software, your source code, is unaware of the new roles. And if you actually had some way of deleting this role, then this part of your code would always break until you fixed it. So that's one of the downsides of using this. However, in very simple applications, there's nothing wrong with this. Maybe you have to support 10 users because it's a simple, reporting tool, and the number of users you're supporting are very, very small. Maybe there's an admin role and then everybody else, right? These are very simple apps. That's not really a big deal. You can use this kind of stuff. It's not that big of a problem. But for larger apps, or when you have to support custom functionality and who can do what, then this becomes very, very burdensome and will actually incur a large cost in your software overhead because you have to go back and fix it all. This is an example of how you do security checks by permission. Right? This is the fine-grained approach of how you do authorization in source code, and it's much, much more resilient. And the reason why is because, let's say I get my current user, then I construct a permission object or an instance that represents an action on a resource. And then I just want to check, is this current user permitted to print to LaserJet 3000N? Right, this is a very, very powerful construct in Shiro, and this is what we call an instance level permission or instance level access control. In your source code, you're allowed to go down to a very, very fine-grained level, and you can actually control individual instances of objects in your system. You can turn them on, turn them off. You can specify any number of actions that you can take on a resource. Very, very flexible and powerful thing to do in source code. And the benefit here is that permission objects, because remember we were talking before, they represent the what of the application. It mirrors or represents the actual concrete functionality that your application can do. When you start to do permission checks like this based on functionality, you only have to change these things when your source code changes, not the other way around. So this is a lot safer in source code. This is how we like to tell people, if you're looking for a cleaner way to do security in source code, we highly recommend this one and not the role-based approach, because these things change when your functionality changes, whereas roles and groups can change and come and go whenever you want. This is an example. It's the same subject, right? Current user represents the subject, and this is how we're doing it with a string instead of a permission class. So if you don't want to implement our permission interface, you can pass in a string. So what we have here is we're saying the printer, this is the resource type that I want to act upon. Print is the action I want to take against it. And the LaserJet 4400N, 4400N is the specific instance that I want to act upon. So this is a string-based example of the same thing that we just saw in the previous slide. The benefit here is that you're not forced to implement an interface, and you can construct it via a simple string. The downside is that you don't have type safety. And if you needed more complicated permission capabilities that are outside the scope of what this represents, you're going to want to implement your own permission objects based on that interface. So, depending on your application needs, this is fine for 80% of the people who work with Shiro. But it's a little cleaner way so you don't have to go through the process of implementing the interface 5-6 times depending on how many resources you have. If you don't want to do code level checks, we can do them in annotations as well, right? This is the second way of doing authorization. So we've got a number of annotations that allow you to annotate methods. And so what this says is that in order for the current user to invoke the open account method, they have to have the teller role in order for the method to be called successfully. If they don't have that role, the method will never be called and an exception will be thrown. That's the general construct for permissions, or excuse me, for annotation level access control. Same thing with permissions, right? We saw the string-based example before. You can do the same thing with this annotation. You can specify, in order for me to call, or in order for the open account method to be invoked, the current user has to have the create account permission in order to do that. So again, this is a slightly safer variant than a role-based annotation because this reflects functionality, not an implicit role construct. That's a great question. The level or the type of access that's occurring is based on business rules, right? That's kind of what you're getting at. You can use permissions to limit yes or no kind of answers based on the kind of data you need to access. But if you need to do things like table joins based on this user, I want to get this information, then you have to go to your database, or you can use another mechanism. If you use things like Hibernate and object caching or distributed enterprise caches that maintain object representation instead of table joins or any of the NoSQL types of systems that are out there, they will be fine with this approach because it is more of a, can I see this object, and if so, let me go pull these objects, right? You can do that with permissions, but if you need to do joins or complex business-like restrictions of views, then you're going to have to drop down to the SQL level. So this will get you pretty far, and depending on the backend system you're talking to, it might even get you to 100%, but there might be certain cases where you can't rely on this. Let's talk about session management a little bit. So we've talked about authentication authorization, and honestly, that's where most security frameworks stop. Those are the only two things that they really care about. JAAS, Java Authentication and Authorization, Spring's security to a large extent really heavily focuses on those two things. And most frameworks, or at least none that I've seen in the Java world, focus on session management and cryptography all that much. So we'll talk about Shiro session management and why it exists. We define session management as managing the lifecycle of a subject-specific temporal data context. It's kind of a mouthful, but all it really means is it's very similar to the HTTP session that you're all comfortable and happy using in web applications, right? An HTTP session is specific to a particular request. In Shiro, sessions are specific to an individual user through the subject. So you can access data and retrieve it later for that particular user only by using our subject API. Here's some features about the subject support. Remember I was telling you in the beginning of the presentation about this cool government application I was working on? Well, one of the things that they required is that, this was way back in the very sad days of EJB 2.1, but what they wanted to do is they said, okay, when I'm using the web application, I want to be able to access the session and store data in here and do all that kind of stuff. But, oh, by the way, we have a Swing desktop application that will be running concurrently with that user, and I want to be able to access session state on the desktop application too. That was a really big problem for us back then because with EJB stateful session beans, you can't share that kind of state with external clients. So you want to fast forward a little bit to now, you can sort of think of this as, maybe I've got a Flex application or a Silverlight application or something like that that's talking to the server, and it needs to access session state the same way that session state is accessed when I'm viewing web applications, right? Technically different client technologies, browser versus desktop, but Shiro has the ability to allow you to get access to data no matter the client technology, because all of our stuff is POJO J2SE based, right? We're not forced to implement some sort of J2EE specification. All of our session objects are POJOs that are managed in memory in the server side, and via remoting technologies, whatever you choose to use, you can access the session data however you wish. So if session starts or stops or expires or whatever, you can listen for event triggers, there are event triggers that you can listen to for events and react on that accordingly. Sessions retain the host address of the machine that initiated the session, So you can find out from what IP or hostname that they're coming from when they started the session. We've got inactivity and expiration support. And what this kind of means, there's this touch method. We'll talk about it briefly a little bit later, but it helps when you're building rich client applications. And I'll talk about how. We have transparent web use, which is really great because it means that if you're running your web app, the Shiro as a framework implements the HTTP session API to sit on top of the Shiro's native session. So if you have a whole lot of source code that exists already that's session-based, that uses the standard servlet API, you don't have to change any of that. You can still use the existing source code, and any calls to HTTP session will delegate down to Shiro. And the reason why that's beneficial is because Shiro has a whole bunch of support for enterprise caching and distributed clustered sessions. And so the benefit there is, how many people here have tried to cluster sessions for web applications? We got a bunch of them. Did you do it like in a Tomcat specific way, or did you like turn on Tomcat clustering or JBoss clustering, right? So the issue with those solutions is that once you set that up, you're tied to that container, right? When you use Shiro, we're agnostic. So you can turn on session caching or distributed sessions in a cluster for failover and high availability and all that stuff. And you don't have to change your source code based on what container you're running in. So whether it's JBoss or Tomcat or Jetty or anything, you don't have to change anything because all the clustering guts are managed by Shiro, and we can talk to any of these other mechanisms on your behalf to spread that data around. So it's nice because you're not stuck with a container-specific mechanism. So the question is, are we abstracting away the container-specific mechanism for session clustering, or are we implementing a whole new mechanism? And the answer is that kind of both, right? Shiro has internally its own session manager. It manages session lifecycles, invalidation, expiration support, all that kind of stuff. But it can be plugged into a cache API. And that cache API can sit on top of any number of commercial caching products like Terracotta with EH-cache or Gigaspaces or Coherence, right? Any of these products. And through that very simple, thin API layer, you can get a full distributed clustered session environment with very, very little work with Shiro. As long as your cache API can talk to any of these mechanisms, whether it's like JSpaces, any of these things can be used to send the data around the network. And as long as Shiro can just talk to them, then you're okay. So the question is if I use Shiro's session clustering capabilities, that means I no longer have to use the containers mechanisms like Tomcat's clustered session manager. And if I do that, what's the benefit of it? Like what's the impetus for me wanting to do that? Is that right? The answer is that, for one, it's not container specific, so I can move from Jetty in testing to Tomcat in production, or Tomcat in beta and JBoss in production, and I don't have to change anything, right? It all still works. And the other thing is that there are things that we can do with sessions that are not part of the servlet API that a lot of people request. Like, what if you want to find out if user J Smith is logged into the application? Right? There's no way to do that in any servlet-based application as it stands, right? Because you have to know if user J Smith has a session to begin with, and if you know that, then you can say yes or no. They're currently using the system or whatever, right? We have the ability in our session APIs to maintain that information, so you can use that as a benefit beyond what is available in a normal servlet-based session mechanism. Okay, so these are all the features of the session management capabilities in Shiro and why they exist. Let's talk about the API a little bit. So we get access to the currently executing user. Just like the HTTP servlet request, if I call get session without any arguments, it will return the session that exists already. And if there isn't one, it will create one for me and return it. Right? Same thing as the servlet request API. If I want to get a session, but I don't want it to start one for me, if it doesn't exist, then I can pass in an argument for false, and then it would return null if the session didn't exist. Otherwise, it would return the one that already existed. Right? Same exact stuff that we see in the servlet request API. And then, of course, there's the methods on the session that you would probably expect, and they're just almost identical to the HTTP session. We can find out when a session was started, the last time the user accessed the session. We can get our attributes set them. We can set the session timeout on a per user basis. And the touch method is kind of cool. This is something new that's not in the servlet API that you get out of Shiro's API. By the way, if you are using the servlet container sessions, you can call touch and it will still work in the same way, right? We've got some stuff under the hood that will make it work in a normal servlet container environment. But what this method is for is that nowadays when everybody's writing rich client applications, RIA applications like Flex apps and JavaScript apps, there are potential uses or potential periods of time when the user might be legitimately acting with the app or interacting with the application. Maybe they're clicking buttons and viewing some data. But in the course of that interaction, maybe they never needed to interact with the server. Maybe the client had the data that it needed already and they could do whatever they needed. Maybe it's an imaging application, they're drawing stuff or whatever. But the point is that in that time frame, maybe they didn't, maybe the front end application didn't need to talk to the back end server. Well, if that happens long enough, by default 30 minutes, then the server-side session will expire, and the front-end application will never know about it, and the next time they try to make a server call, you get this nasty exception, and they have to log out and log back in again, all that kind of stuff. So as part of Shiro's API, we have this touch method, and all it does is proactively update the last access timestamp automatically. And so your rich client apps can call into the server and invoke this method to make sure their session does not time out. Right, so it's a nice feature that can be used in RIA applications. It's a nice little usability feature. So that's pretty much it about sessions and the API. I guess the takeaway from the slide is that it is nearly identical to the HTTP session API. It's got some minor adjustments. All values are specified in long milliseconds instead of the HTTP sessions integers for seconds. There's a little bit more control. There's a finer grained control on a lot of these things. And you can see the whole API online, but it's very similar to HTTP session. And so there's almost no learning curve in using this stuff. One of the things, interestingly, that we didn't talk about is that the amazing thing about all this session stuff is that you don't have to be deployed inside of an HTTP container or an EJB container to get this stuff. If you needed sessions in a standalone desktop application, you can get it out of the box with Shiro's API. So if I call subject.getSession, it'll know. It's like, okay, I'm not running a web environment. I need to automatically engage my enterprise session management so I can provide session state for these users that use this application. So with one API, you can get session support across web apps, enterprise Java apps, like ears, ear deployments, or even desktop applications, command line applications. And we've heard of people using this in cell phones as well, in mobile apps. So you get a single unified session API that works in all environments, regardless of deployment environment. So the question is if I use Shiro's session API, how portable is it across different environments? Because sometimes session listeners work in one application server and they may not work in another web container. The answer to that is it's because it's a clean room implementation and we had to implement the specification, all of our stuff works across any server that it's on. If you're using Shiro's native sessions, right? The default behavior is to just sit on top of what container provides already. So you're not going to get anything extra if you just use Shiro's default configuration. But if you turn on native sessions, then it's our own implementation. It works across the board on any application server, any web container, and you can store data, retrieve it. You can implement session listeners, and it will work. And we've got all sorts of stuff going on in the background to make sure it's safe. Like we have a listener thread to make sure that sessions don't orphan and that it doesn't blow up the memory on the box. We've got a lot of those safeguards in place to make sure that that stuff is maintained no matter the deployment environment. Mm-hmm. Yes, that sits on top of the servlet container.
What is your native session? Class is like single session and that's from the class name.
What's the question's what's the native session?
Yeah, class name.
The class name of it is just simple session. And that's the class name that we use to maintain that internally is simple session, and that's just a POJO, right? And the server maintains that pool of session POJOs depending on or based on the runtime environment. Cryptography is the fourth cornerstone of the Shiro's API offering. And what we define cryptography as is that it's the act of protecting information from undesired access by either hiding it or munging that data into nonsense so people can't read it. And there's two main core elements of the cryptography support in Shiro, and that's the notion of ciphers and of hashes. We define ciphers as really they're algorithms that execute, and they can either encrypt or decrypt data based on public or private key pairs. A symmetric cipher is one that encrypts and decrypts using the same or trivially similar key. Right? An asymmetric cipher is one that uses different keys to encrypt and another key to decrypt. And we support both concepts in the API. What's a hash? Hash is a one-way irreversible conversion of an input source. In the Java API, or excuse me, the JDK, they call this a message digest. Both terms are cryptographic hash and a message digest are the same thing. What are they used for? It's to transform credentials, so passwords, biometric information. It's a one-way conversion, so you can't ever see what the original input value was. And it's very, very safe to do this with passwords to make sure that you can't ever find out what users' passwords are, or if your system's ever compromised, they can't find out what it was. And Shiro's hashes will work with any type of data with an underlying byte array. So input streams, files, byte arrays, strings, character arrays. You can hash any of that. So why does this stuff exist when the Java cryptography extensions exist? Well, for one is simplicity, right? One of the key components or the key reasons for why we exist is because we want to make things a lot easier to use. I don't know about you guys, but when I have worked with the JCE API directly, I want to go home and run away screaming and crying because it's insanely painful to use and I hate it. So what we wanted to do is take the concepts of cryptography that's offered by the JCE APIs and just make them normal for the mortal human beings that we are. It's a much easier to understand API. In the JCE APIs that come out of the box in the JDK, they're all very procedural stuff. There's one cipher class in the JDK that represents all ciphers. So whether it's an AES cipher or a DES or a symmetric key cipher or asymmetric key cipher, they're all represented by one physical class. And that just boggles my mind because Java is supposed to be an object-oriented language that abstracts out behavior based on, subsets of data, and they completely violate that concept with the JCE. So our stuff object-orientifies, if I can make that word, a lot of the stuff that's in the JDK. It makes it a lot easier to consume as a developer, a lot easier to use in your own applications. And to that point, it is interface-driven and POJO-based. So I can instantiate objects, I can implement an interface, I can subclass them based on my needs, and life is good again. So some of the features of our support, right? So we have an OO hierarchy in place. The root of the hierarchy is this JCA Cipher service, and that's really the base implementation that hides a lot of the JDK's guts away from us. And then we start to go into a hierarchy. We've got an abstract symmetric cipher service, which handles symmetric cipher algorithms. We've got a default block cipher service, which handles block ciphers, which are types of symmetric ciphers. We have an asymmetric cipher service. So you can sort of start to see this hierarchy of objects based on what we need as developers. In the JCE, if you need to get access to an AES cipher or DES cipher or any of these other things, it has this convoluted process of using a factory method. So I'm gonna talk to the Cipher API and I'm gonna give it what they call a transformation string, and it's terrible. It's basically, what is my cipher mode of operation, the block mode of operation, what's my block size, is it 8 bits, is it 16 bits? There's all of these things that you have to worry about, and if you've never done cryptography before, you don't know a lot of the mathematical concepts behind it, so it can be really, really overwhelming. So in Shiro, we've abstracted these things, these settings, away behind simple POJO-based getter-setter methods. So you can set the block size, you can set the padding scheme, you can set the mode of operation. You can do all these things if you know what they mean. But if you don't, all of them are set to sensible defaults for most secure applications. And then you can go ahead and munge with those values all you want once you learn about them. But you can rest assured that when you instantiate the AES Cipher class, it's going to encrypt things with AES encryption in a secure way, and it's easy to use. Also, one of the things that we've done with our Cipher support is that we have more secure default settings than what's available in the JDK. In the JDK, the AES cipher, the DES cipher, they are initialized by default with something called a block mode. And a block mode really tells the cipher algorithm how to transmit data from plain text into encrypted data. And there are many different types of block modes, and this is all kind of very boring and not really that important, but the default block mode that Sun uses, or now Oracle, is not very secure. It's called ECB, Electronic Cookbook Mode, and if you do some Wikipedia Googling or whatever, you'll see examples of why ECB mode is not a very good mode for encryption. It doesn't really hide data all that well, and reasonably good cryptanalysts can easily crack code, or more easily crack cipher data that is ECB mode enabled. So all of our ciphers do not use that Sun Oracle default. We use the CFB mode, which is accessible to all JDKs. And it is a much, much safer mode for encryption. The other thing that we do is by default, we use something called an initialization vector for every encryption operation. And what that means is an initialization vector is really just a seed, right? You know, you'll have seeds for password data or salts for password data. The initialization vector is just a randomly generated byte array, seed data. And what that does for a cipher is it uses it as its kickstart to encrypt what comes after it. So if I've got a text file, you know, hello world or whatever, it will generate an initialization vector, and then it will encrypt that text file. And why that's beneficial is because I can take that same text file without changing it and encrypt it multiple times with Shiro's encryption support, and the output will be different every single time. And that's really important in the world of cryptography because even though my data is the same, my cryptography output's different, and it makes it much harder for cryptanalysts to try to intercept that data and crack it. Because if that data changes every time, they have no patterns that they can look into to try to crack the data. So all of these features, these benefits, the CFB mode, the initialization vector, it's all built into Shiro by default. You don't have to configure anything. You get these benefits if you start using the APIs directly. So this is what our Cipher service looks like. It's a simple interface. It's got 4 methods on it, 2 encryption methods and 2 decryption methods. They're single operation methods, so once you call it, when it returns, your data is completely decrypted or encrypted, whatever the case may be. You don't have to wait for it. Cipher services in Shiro are stateless by default, whereas the JCE ciphers are stateful, which means that you as a developer has to manage their state. You have to make sure they're thread safe and all this other stuff. These are thread safe by default because they're not stateless, or they are stateless, they're not stateful. And they support both block operations, byte arrays, as well as streaming operations. So you can be sending a video stream through and encrypting it and then send it right back through and decrypt it on the fly. But they will, they're single operation methods, so when this returns, your work is done. You can go on with your data, which is mostly what most developers want. If you've ever worked with a Cipher instance in the JDK, it's very, very painful. You have to call this do final method and pass in initialization vector data, and you have to manage all that stuff yourself. This is an out of the box, ready to go. You're secure and safe. In addition to ciphers, here's some the Cipher features. Here's some of our hash features. Again, like the JDK, it's all procedural, right? They have this message digest class, and you can get this algorithm or that algorithm. With us, we have default class-based implementations based on the APIs that you want to use. So we have an MD5 implementation of a hash. We have SHA-1, 256, 512, etc. We have built-in hex and base64 conversion of the data, which is really, really nice because if you print it out to a file or put it in a database, you don't have to worry about how do I hex encode something or base64 encode it or decode it. And then on the hashes, we've got built-in support for salting and multiple iterations. Do you guys know why salts are important for hashes? Like, for example, let's say we're going to take a password. You have a password for a username. Why would I want to salt it or use a repeated number of iterations? Any ideas? Right, yeah. So user A and user B could technically have the same password, but if you use a salt, like an initial seed, then it makes those two values different, which is nice because you don't have collisions. Did you guys hear maybe, it must have been maybe 5 months ago maybe, that Atlassian's Jira product was compromised? And a number of public installations, like I know the Apache Software Foundation's was, Codehouse and some others were compromised. The reason why is because Jira as a product was not salting their users' passwords. So that's a real-world example of why you really want to use salts in your own applications if you're protecting your end users. Repeated hashing. Why is repeated hashing valuable? Like, if I have a password, and I can hash it once, right, with that salt, and, it's salted, it's good to go. But I've only done it once. Why would I want to salt the same password multiple times? It's all about execution time. So if I'm an attacker, and I'm trying to thwart a system and I want to sort of compromise an account or multiple accounts, when I hit that login button or I have a script that does it for me, if I have to wait 1,024 times for that hash to occur, I as an attacker am waiting a lot longer for my scripts to try to execute and compromise an account. Whereas an end user, when they, like a legitimate human being, enters their username, password, hits submit, the time difference between one hash iteration and 1,000 iterations is negligible for the user. It might increase the login time maybe 0.4 seconds, and most people never care about that kind of thing. But when you compound that with thousands and thousands of hack attempts, it really, really makes a difference for the attacker. So here's some examples. This is our hash interface. Very, very simple. We can get the bytes associated with a hash, and we can call toString or two hex or two base64. To return the encoded data of that byte array. Much easier than using like Commons codec or some other library. So this is our hash interface, and here's some examples of how to use it in your applications. This is much, again, going on the concepts of object-oriented concepts. This is a lot easier to use and understand than using the message digest class, which is procedural. So if I want an MD5 hija or a hash of foo, I can just pass it in as an argument, run 2 hex, and there's my hex encoding of the foo MD5 hash. I can also pass in a file. I can get the hex value of that. So this is commonly used for checksums for files, like if you want to download something and verify its integrity, you can do that. And here's an example of using an SHA-256 hash to store a password. So here we've got a password, we've got some salt, in this case probably a random byte array, and we're passing in, we're saying we want to iterate 1,024 times, and then finally base64 encode that resulting hash and give me the text value. So in a single line of code, you've done quite a bit of work in regards to hashing, and you haven't resorted to any procedural factory-based APIs. All right, so let's talk about web support really quick. We have a simple Shiro filter that you can take and deploy inside of, or you define it inside of web.xml. And that one filter definition will give you all the support that you need for Shiro, at least, in a web application. It can protect all URLs. So any kind of web request that comes into your system, Shiro can protect it. We've got a pretty innovative filtering mechanism that allows you to protect URLs, but define URL-specific filter chains. It's a feature that we haven't seen anywhere else. And if you use Shiro for nothing more than that feature alone and you didn't use it for anything else, I think it would still be worth its use because it's a pretty powerful concept. We have Jsp Tag Support, and again, like we talked about before, there's transparent HTTP session support. So if you are using Shiro's native sessions, we've implemented the HTTP session API and the Servlet 2.5 API, so you don't have to change any of your web code and it'll still work. So that's all transparent to your code. So let's talk about how you would, in a simple case, enable this. This example shows you two things that you have to add to web.xml. You have to add the Shiro filter definition, and then you have to add a filter mapping that tells the servlet container when to execute that filter. So in this case, we're using an INI Shiro filter, and what that is it's a filter that uses the INI configuration format in order to get all of its work done. Everything in Shiro is 100% POJO based, so you can, and I often do use it in other environments like Spring. There's people that use Shiro inside of JAAS environments, so they use these more powerful IOC dependency injection kind of ways to configure Shiro. But as a base, if you don't want to use any of those, or if you want something out of the box really quickly to use, like in a standalone application or a command line application, you can configure almost everything in Shiro with the INI format. So in this very simple example, we're showing you how you would configure Shiro to run in a web app. So we've got our Shiro filter definition, and the config initialization or init param is all of our INI config. And so in this config, it says, okay, I'm going to have one realm in my application, and it's going to be some class. And then I'm going to assign the realm to the Shiro security manager. That's all that's really required in order for you to have a custom realm supported in your web app for Shiro. That's it. Just these two lines of code or configuration. In addition to setting up the security manager guts and the object graph and all that other stuff, we can, of course, start to talk about URL-based security. There's a whole lot of approaches and many different techniques, but in the interest of time, we'll talk about what each of these means. When in the URL section, each one of these entries represents a path that the Shiro filter will inspect, and for any request matching this path, it will execute a filter chain in order to verify that it's protected. So in this particular example, we're saying anybody who's trying to access the account part of the application has to be authenticated. And if they're not, the authentication filter here, which is part of Shiro's API out of the box, will automatically redirect you to a login. And once you've logged in, then you can go back to these URLs. In this example, we're saying that in order for you or for a web client to access anything under the remoting URLs or remoting path, they're ANT style expressions, by the way, which is why you see the double stars. So if you've used ANT, you know that this means remoting or any subpath underneath that. If they access remoting, they have to be authenticated. They have to have the B2B client role, and then any other number of filters that you can specify here, which is a really, really powerful feature, again, because there's nothing that we've seen in any web framework that exists that allows you to define per path filter chains. And all of these, Shiro provides something like, 8 or 9 or 10 default filters that you can use in your definition. So maybe they're authenticated, maybe they have to have this permission, maybe they have to have this role, maybe they have to be a user, or they have to be remembered or authenticated, right? A lot of those scenarios are covered by our default filters out of the box. So that's an example of getting this set up in web.xml. It's very easy to use. Here's some example of some tag libs. So we've got the Shiro namespace or tag library namespace, and you can do stuff like this, where I want to say if the Shiro has the role, or if the current user has a role of administrator, I'm going to go ahead and show this HTML or this JSP snippet or whatever. And if they don't have the role, or they lack the role, in other words, then I'm going to show them something else. So there's all sorts of tags that you can use. So there's guest, there's user, principal, has role. This will print out their username. This means that they're not authenticated and they're not remembered. This means that they are authenticated or are remembered. So there's all these kind of tags that you can use to customize the output of your JSPs or HTML pages or Groovy pages. So that's a very, very brief overview. The takeaways from this are the path-specific filter chain configuration, and that in order to get all of this stuff to work in your app, all you have to do is define one filter in the Shiro filter in web.xml. Moving on very quickly, we'll talk about some threading and concurrency support, and we'll also get to the unit testing case that we talked about very earlier. So the way all this stuff works is that the currently executing subject instance is bound to the current thread. So right, we use a thread context, which is abstraction on top of a thread local, and that's how we keep Shiro associated with threads. This is all fine and well when you're executing logic in the current thread. But what happens if you need to execute logic in other threads, right, that need to retain that user's identity? So maybe you want to dispatch some work, but have it run as that particular user. To support this, Shiro has mechanisms that will run runnables and callables. We also have integration with the Jdk Executor Service. Here's an example of how this thread association stuff can work. So I get my current user. Maybe I get a callable from somewhere. It's some implementation that I've done. And then I call current user.associate with, pass in my callable. And the callable returned will automatically perform subject thread binding and subject cleanup and removal on any thread that executes it. So you can guarantee that when you take this callable that you've created, or runnable, whatever the case may be, and you toss it off to an executor service or a thread pool, you can guarantee that when it executes, it will run as that particular user. So it's not just the current thread, it can be any thread that is user associated. We've also got our own subject-aware implementations of the Jdk Executor Services and scheduled executor services. And the benefit here is because you can, via IOC or configuration, inject one of these implementations into your source code. And then when you create your callable and you dispatch it to one of these executors, the subject association from thread to thread will automatically be maintained by Shiro and these implementations. So what that means for you is that in your code that does this stuff, you never had to reference Shiro's API anywhere. Right? It'll maintain it for you behind the scenes. And so it's nice because it allows you to decouple your code from Shiro concepts, but it'll still retain user identity across threads. We also offer run as support. And what that basically means is that if I'm an administrative user, perhaps I want to run as or assume the identity of one of my application users, because I want to see and do and see everything that affects them. So this feature allows me to assume an identity of another person and sort of act as that user without losing my original identity, so I can sort of see what's going on. So this run as support is used in a lot of different situations. The administrator checking up on a user is just one example. I've seen that used to great effect in call center support kind of situations where a user calls in and says, hey, when I do this, it breaks for me all the time. Well, the call center support guy can assume the identity of that user and then play around to make sure that they can see exactly what that user sees. So that's supported, and this is what it looks like. I can get a new identity. I can assume whatever identity I want. I can call the run as function with that new identity. It's a principal. And then I can, later on in my code, I can check, is the current user running as somebody else? And if so, maybe I want to get the previous principals that they were running. So it actually acts as a stack. You can run as a user, which can run as another user, which can run as another user. Whether or not you let your users do this is entirely based on permission checks. Like you could protect these calls to say, if the current user is allowed to, or permitted to run as another user, only then will I call this method. But there's nothing inherent in these calls that prevents you from calling them. You have to protect them as you see fit based on your business logic. Real quick, unit testing. Talk about these. So the subject is an interface in Shiro. And in that interface, we've got a nested inner class called a builder, which uses the builder design pattern. And so what this allows you to do is that you can use the build, you can construct a new builder, pass in the security manager that's managing your application, and then you can start building the subject instance however you want. You can give it a username that you want to associate with it. You can tell it it's already authenticated. Maybe it's remembered. Maybe it has these permissions, right? You can assign all that stuff to these things directly. And then once you have it, you can use that same runnable or callable support that we just covered in the concurrency part to execute whatever you want. And when you do this, anything in this, any calls to securityutils.getSubject, right? Any calls to that method will work because it's running in the context of this runnable. So a lot of people use that in unit testing to simulate users and to make sure that when their code executes, it runs as that particular user. And then finally, the last thing that we haven't talked about yet, it's super simple. If you want to log out and clean up the user state, close their session, whatever, this is the last thing you have to do for a user session. Is you just call logout and it cleans up everything automatically. So if you are remembered, it will automatically, like in a web scenario, it will automatically clear out and delete the cookie and do all that kind of stuff. So this, again, is a simple web application that's using the INI format because we're not using Spring or Juice or anything like that. And in this example, you'll see that unlike the previous slide, we're actually defining some users and some roles. So we're saying here, this is a root user. His password is the string secret, and we're assigning him the admin role. We've got a guest user, guest password, guest role. There's a President Scroob user. His password is 12345. If anybody's seen that movie, you know what I'm talking about. And he has the president role. And of course, there's a Dark Helmet and a Lone Star user. And these are their passwords, and these are their roles. Just associating roles to users like this is all that's required to get them to be created and be assigned. But if you wanted to actually assign permissions, instance level, any kind of concrete permissions, you can do that down here in the role section. You just redefine the admin role, and then this says that we're giving them permission to do everything. The Schwartz user has permission to do anything that they want with a lightsaber. Right, and this notation here that you're seeing is part of the wildcard permission syntax. You can check out the Java doc to see how the permutations work when you define these tokens. But it allows you, it's pretty powerful and allows you to do a lot of things. Finally, here's an instance level permission saying the good guys are allowed to drive Winnebagos with the ID Eagle 5. Right, and we've got some URLs here. So there's login. The account, if you go to the account page, you have to be authenticated, and if you want to execute any remoting calls, you have to have these roles. Right, we covered those very briefly. So I will fire up the web app. Ah, interesting. So you saw me. This is actually kind of a cool test. I just started the web application, but I haven't logged in yet, and that's because earlier, before the presentation started, I was playing around with it, and I clicked the Remember Me option. So it automatically remembered who I was based on that cookie, even though the server had shut down and then come back online again. So I'll show you, let's see, a log out, so I can log into the home page. And then we saw account section here. Where is it? We said in order to access anything under the account path, you have to be authenticated. So I can go to the account. And as you saw, the account page, what it does is it's like your my landing page or whatever, where it has user-specific information. And it didn't show it to me because I don't have the ability to see that stuff until I log in first. So I'll just use star as an example, Vespa, remember me. I can log in. And now I can see the account page. Right? It was intelligent enough to say, okay, you've authenticated successfully. Now I'm going to redirect you back to the page that you were originally trying to access, because it's a nice usability feature. So I'm on the account page. I can go to the home page, and you'll see in here. Let me see if I can find the home. You'll see that we've used a lot of these Shiro JSP tags. Right? We've got, show this text if I'm a guest, or if I have this role, I want you to show this stuff. Roles that I don't have, show these things only if I don't have the particular role. And you can see that reflected in the web page. Right? I have good guy, this kind of stuff. If I log in as a different user, you can see that my roles are different now because of the way the JSP tags evaluate. So very, very quick demo. You can play with the INI file. You can play with the tags, and there's a lot more documentation on the Shiro website. Thanks for your time.